Okay, so today we're looking at the following example, sketching of polynomial functions. So how do you sketch such a polynomial function? First of all, you need to look for the roots of this function. How do you look for the roots? You need to look for the roots of this function. So the roots are found by equating the factors of this polynomial to 0. So equate each factor of this polynomial to 0. So we say x plus 3 is equal to 0, x minus 2 is equal to 0, x minus 1 is equal to 0. Then from the first equation, our x is equal to negative 3, x is equal to 2, and x is equal to 1. So these are the roots of this polynomial. After finding the roots, you find what is known as the y-intercept. How do you find the y-intercept? You find that by equating the value of x to 0. So you let x be equal to 0, and then find the value of the function at x is equal to 0. So you put 0 plus 3, 0 minus 2, and 0 minus 1. So you get 3 minus 2 minus 1. So there you get positive 6. So this function cuts the x-axis at y is equal to positive 6. After that, from the given roots, this implies that when you draw the x or y plane, okay, the graph will cut the y-axis at negative 3, at 1, and at 2. That will be the nature. So to pass through this point, that point, and that point. So the roots are the points at which the given graphs cuts the x-axis. So this graph may have these possibilities. It may look like this, okay, or it may look like that, passing through this point, passing through that point, or that, or it may also look like this, like that, passing through two, or it may look like this one. So how do you know the actual nature of this given function, of this graph? So for you to determine that, you must do some testing. So you get the roots, put them on the line. There is your negative 3, your 1, and your 2. You test the nature of this function for the numbers from negative, for the x less than negative 3, then for x between negative 3 and 1, and for x between 1 and 2, and finally for x, for the values of x greater than 2. So for the first part, we pick any number less than 3. So let's pick x is equal to negative 4. Find the function at x is equal to negative 4. So when you substitute in the given function, this is the given function, put negative 4 there. If you put negative 4, you're going to have negative 4 plus 3, negative 4 minus 2, and negative 4 minus 1. Then from there, you're going to have negative 1 minus 6 and minus 5. So this is going to give you minus 30. Minus 30. So the function is negative for the values of x less than negative 3. So why do we do this? For negative values of x, for negative, it implies that the graph is below the x-axis. For positive values of a function, implies that the function is above the x-axis, okay? The function is passing above the x-axis. So for the first value, which is values less than -3, we should expect it to be below the x-axis. We go for the values between -3 and 1. We can pick any value. Let's pick a 0. 0, put 0 there, plus 3, 0 minus 2, and 0 minus 1. You're going to get a positive 6. Getting a positive 6. So between -3 and 1, it should be above the x-axis. Now let's test from 1 and 2, between 1 and 2. So you can get 1.5, okay? And substitute 1.5 in our given function there. You're going to have 4.5. You're going to have 1.5 minus 2. You're going to have 1.5 minus 1. This is 1.5. This is 0.5, negative 0.5. And this is positive 0.5. Multiplying this, 45 times 5 times 5 is 1125. How many decimal places? 1, 2, 3. 1, 2, 3. So to be there, the point will be there, and then positive, negative, positive. You're going to have negative there. So negative. So it will be between 1 and 2. It will be below the x-axis. Okay. So it is. I won't go there first. It is below the x-axis. Now test where will be the function for values greater than 2. So pick any number greater than 2. You can pick. I'm gonna pick 3. It's a convenient one. Then substituting this function, putting 3 there, we're going to have 6, 1, and 2. Multiplying this, you're going to get positive 12. So it is positive. So from 2 going upwards should be above the x-axis. Okay, above the x-axis. So the graph will be of this nature. Okay, so write your -3 there, your 1, and your 2, x, y-axis 0. So we're saying that from numbers less than -3, it will be below the x-axis. It will be below the x-axis. So it will be somewhere to look like this. This is the straight line I've drawn. We're just looking for the nature of the graph. Then from a -3 to 1 to be above the x-axis. So it will proceed. Okay, and it will cut the x-axis. Remember, to cut the x-axis at +6. Okay, this is the y-axis at +6. To cut the y-axis at +6 here, at 6. And then between 1 and 2, it is below. So it should look like this. So naturally you can just connect these 2 points like this. And then from 2 going forward, it is above. So the naturally you can now just connect these 2 points. So the graph has the form, this form, okay? But remember, these are straight lines we're drawing. So this is just a rough sketch. So now the actual sketch will look like this, okay? You have your x or y plane, okay? It's gonna have this shape. It's going to have this shape where this is your 1, this is your 2, this is your -3, and this is your 6. Okay, and this is your graph of x-axis. This is your 0. So this is a rough sketch. So this sketch does not tell us the maximum point or the minimum points. It just shows us the nature of the graph and why it is cutting the x axis and the y axis. Thank you.